Because I practice the SAT a lot, I know looking at this question that this is really just about unit conversion and that I need to use ratios to organize all of the information that I'm given. So when I see especially that they give me a unit conversion in the question, my instinct is to start with the question itself and try to pull out of it a rate of some kind. So what I see here is they're talking about the number of glasses that can be filled with 1 gallon of water. So that's kind of like a rate, right? It's going to be X glasses per 1 gallon, right? And so what this is going to do is this is going to let me kind of create some sort of symmetrical set of proportions that I can use to understand all the information that they're giving me. So one thing I can do is, well, eventually what I want is I want to have the proportion have the units on the same side. So this is why it's so important to show your work on a question like this, because we want to make sure that we're matching up all the units. If we have a proportion with the same units on the top and the same units on the bottom, we are good to go. We know that our math is going to work itself out. So in this case, what I want is a certain number of glasses on the top and gallons on the bottom. So now what I do to create another proportion is I don't even worry about getting it perfect. I just look for a rate somewhere in the question that's going to get one of those units correct. So I'm going to start with the most obvious thing here, which is that there's actually a conversion that involves gallons in the question right there at the end. So I'm going to include that. Now, it's going to create a bit of a problem because even though it has gallons on the bottom, which is what I want, it's also going to have now a unit I don't want, fluid ounces on the top. But that's okay. My purpose here is not to see the big picture. My purpose is not to get all of the units perfect at first, because when these get complicated, there's going to be multiple steps. The goal is to get something that lines up so that I can see, okay, I've got to start. And now I know where to go, which is to fix the top so that I don't have fluid ounces on the top, but I have glasses on the top. I need those top units to match. And the way to do it is to use more fractions. So what I'm going to do here is find another fraction, another rate, that's going to put fluid ounces on the bottom so that I can cancel it out, right? Because when I multiply fractions, if some number is on the top and on the bottom, it cancels out. That's how we reduce fractions. But that also works when we think about the units. If the unit is on the top and on the bottom, it cancels out. So I want to get rid of fluid ounces, so now I'm scanning for some rate that involves fluid ounces. The question itself does not have anything about fluid ounces except what we've already used. But that's why we always need to go back to the story that a multi-part question is revolving around, because we need to make sure we're not losing any information that might be necessary. So in this case, they do tell me that is a 16 fluid ounce glass. So 16 fluid ounces per 1 glass. And look what happens. Now I can get rid of the fluid ounces and I have the same unit on the top on both sides. Glasses to glasses. That's how I know that I've set up my work correctly. That's how I know that I can now proceed with the arithmetic portion of the unit conversion. So what do I do? Well, let's scroll down here. We just bring down this fraction because it's the same. I'm going to be able to now get rid of the units because I know that they all work out, so I'm going to just kind of ignore them. And I can now multiply across the tops and across the bottoms of the other set of fractions, because that's just how you multiply fractions. So in this case, 128 times 1 is just 128. And 1 times 16 is just 16. And look, if this were a more complicated situation, I might need to cross multiply and solve for x using that method. But because x over 1 is just x, I can just drop the fraction entirely and just do in my calculator 128 divided by 16, and I get 8, which is choice B, which is the answer. So there we go. Now, are there other ways to get this without doing this kind of like weird fractions thing? Yes, there are. But speaking from experience, I know that the SAT likes to take advantage of you on these unit conversion questions. They know that if they give you more units to convert, if they give you weirder units to convert, it gets harder to understand when you're supposed to be multiplying, when you're supposed to be dividing. It's easy to forget a step, and all of those mistakes that you're likely to make are going to be wrong answers. So if you make the common mistake, you won't know it, because your answer will be there and you'll feel pretty confident in what you've done. So we're trying to prevent a careless mistake. That is very important on the SAT, where there's no partial credit. So we need to make sure that when we hit a question where there's a high probability of a careless mistake, that we have a good system in place that helps us prevent that. And that's exactly what we're doing here. It's going to come up on lots of questions on the SAT. And I use this system no matter what, because I don't really know if I'm dealing with one of those places where I'm likely to make a mistake. We have to treat every situation like it's a possible mistake, and that's how we catch most of our errors. This is something that I learned actually in chemistry class in high school. It was called stoichiometry. Let me write that word down, stoichiometry. I've adapted it to deal with ratios and to work on the SAT, but it's basically the same principle. Is we're using rates and fractions, the properties of fractions, to keep ourselves organized. And when all of our units check out, we know we've done all the right work, and we can proceed with the arithmetic and get the right answer. Hopefully, it helps you stay organized as well.